Okay, so your written test number 2, I just met with the TA, so I believe they have the result. I just need to do some random check. That's what I normally do. I'll try to get back to you on written test number 2, either maybe late tomorrow, Friday, or over the weekend. You definitely get a result back, okay, about the written test 2. And then for your programming test number 3 that you took yesterday, I'll meet with the TA also very soon to do the grading, and then may not be back by next Tuesday, but I'll try the best by the end of next Friday. Okay, you can still submit a regrading request if necessary for programming test 3. Okay, so that'll be the stuff. And then just make sure for your lab number 5, right, you can submit up to December 9th without any penalty. Just make sure you do that. And also for the exam, just make sure you do the background studies for abstract classes and interfaces, right? You got all the materials there for you. You got slides, you got lecture recordings, you got example code, etc. Everything's there. You just gotta choose the one that can help you learn the concept so you get ready for the exam. And then, yeah, during the exam period, I'll try to host an office hour. You know, I will just decide some time, and then I will reach out to you. You'll be in person, and then we should be able to host at least one review session to go over maybe some sample questions, maybe your doubts about any parts of the course. We can also do it as well. I'll reach out to you. I think our exam is rather late. It's around 16th of December, so we definitely have time to plan these things out. But if you want to speak to me, you can also do that. Right? I still got office hour next Monday. Okay. Any questions? Yes. There will be. I wouldn't call that like a practice exam. It does contain some example questions. I will release it. I'll try that maybe by Tuesday or maybe Wednesday, your study day, the latest. And then next Tuesday, the last class, I'll also try to talk about the exam as well. Just give you some tips, like a coverage, etc. Okay, yeah. Okay. Okay. Let's do a very quick recap, and then we should really move on with more examples. Okay. Yeah, we just got to move on with the recursion. Okay. All right, so last time we introduced the idea about recursion. I think at this page here, it's a very simple pattern, simple yet powerful. It's really the pattern that you're going to apply to between simple and sophisticated problems. So it's really the same pattern. Okay. Just remember every time you have a small problem, in which case you can solve it directly. So for example, if you got empty string with length 1, string with length 2, etc. So normally you'll get 2 or 3 base cases, no more. Okay, you don't really need to have too many base cases. Just about one, excuse me, between 1 and 3. And then anything that's larger than the base case, we call it the recursive case. And then we got a big problem over here that we cannot solve right away. In which case, we'll divide that big problem into small problems over here. And then for each small problem, we're going to make some recursive call and assume that each recursive call is going to give back to us the correct result. And from there, we're going to combine the result together and then make the ultimate solution to return. So that's really the pattern you're going to see for every problem that we talk about in the class or anything you will see outside, the lectures. And one thing just to remind you very quickly, okay, so on the lecture side, you will see there's something kind of pointed out to you earlier. So if you see under recursion, so there's a PDF notes over here about solving problems recursively, right? If you click on that, I think some of the problem we have gone through, you can already take a look at this one here to really revise about the concept. I try to somehow talk about how the general pattern has been instantiated for each of the problems that we discussed in the class, especially about how you can think about the base cases, how you can think about recursive cases, etc. Right? It's a very good notes to really summarize about what we have seen for the pattern, right? So just remember to really go over that before your exam. Okay. Okay, and then let's now go through very quickly. And then we have the concept of stack, and just make sure you know how to trace using a stack, a chain of method call basically. But I would say when you're tracing recursion using a stack, it's really still a chain of method call. It's just that we're tracing just the same method with different input values. And we talk about factorial, and just make sure you understand the difference between non-recursive versus recursive solution, right? In the recursive solution, in order to solve factorial of size n, we're going to call the factorial of size n minus 1. and n minus 1 is strictly smaller than n, right? That's a very important principle. Always remember when you make a recursive call, the input has to be strictly smaller. Otherwise, you're going to run into infinite recursion, as we saw earlier. Right, so we did the tracing using a stack, and I also gave you guys some exercise about how to trace Fibonacci, right, over here, Fibonacci number 4, using a stack. So I would say this is an important tracing exercise for you to try it out, to really appreciate how stack can really simulate how the computer program is going to be executed at the runtime. So really make sure you do that exercise. Okay. And of course, we talk about the common errors about recursion. If you miss the base case, or if you try to make a recursive call, but without reducing the input size, right? Both are problematic, right? You definitely want to avoid these two, okay? And then we got Fibonacci solution, right? So that's a recursive one. So for this one here, you can see in order to solve Fibonacci of size n, we have to somehow reuse or make a recursive call twice, 1 and 2. The first recursive call is going to use n minus 1, which is strictly less than n. The second one is n minus 2, which is also strictly less than n, right? So every time you make a recursive call, you want to solve a strictly smaller problem. It's always the case. Okay. All right, and then any questions about Fibonacci factorial? Yeah, these are rather straightforward, right? Okay, these are simple ones, just to get some feel about recursion. And then we talk about some utility methods for strings. You can assume that these methods will be allowed for you to use during the exam if I give you any recursion problem on the string. And if you actually go onto the coding bat, recursion 1, you will see some string recursion problem as well. You can definitely be ready to really give a try on extra problems yourself. Especially for the substring, just remember, when you actually got 0, 4, for example, it's going to include characters from index 0 to index 4 minus 1. Right? It's kind of exclusive on the right hand. Okay? That's something we went over in detail last time. And then the only problem that we went over was a palindrome. Okay? Let's revisit about the idea. How do we think about solving this problem here recursively? Right? So the idea is we want to make sure the string is a palindrome if you read forward and read backwards, they should read the same. And we know that when you try to read forward, the first character to read will be the first character. If you try to read backwards, the first character to read will be the last character. So we somehow take the first and the last character first and try to see, are they the same? If they are the same, then we have a chance that the whole string is a palindrome. But we cannot be sure just yet. We have to dive deeper by go to this particular strictly smaller substring and try to see if that part there is a palindrome. Right? That's one case. Another case would be, I look at the first and last characters, but they are already different. No chance the whole string is a palindrome, in which case I don't need to bother to really go here. So now when I say I don't need to bother, so we did learn something similar to say if the left-hand side evaluate to false, for example, I don't need to go to the right-hand side, right? Short circuit evaluation. That is something you also have to make sure you feel comfortable about using. Okay? So you might be asked to write some program or analyze something about it in the exam. So that's about the recursive thinking that we went over last time. Okay? So what we should do now is apply this recursive thinking to Java code to see how that will look like. Okay, let's take a look. Any questions you have about this intuition here? We didn't do any coding just yet, right? Just talk about ideas. Okay. I would say typically, if you're trying to solve recursion problems on strings or array, some very typical pattern would be you may want to take a look at maybe the first two elements and then look at the rest as a recursive call. Or you might look at the first and the last elements and then look at the middle part for the recursive call. That's a very common pattern. Of course, sometimes you may have a unique problem that you have to somehow split the string or array in a different way. So it really depends. But I would say know the common ones first so you can adapt yourself to the more unique one. All right, let's now take a look at some Java code, right? It's palindrome. Okay. So this one here, so let's just to start with, you can see we're taking a string word. I'll visualize the solution in just a moment. And we say that if the length of the string is either 0 or 1, it should be a palindrome automatically. So these two are the base cases, right? You can see that these are the base cases. Either when the length is 0 or when the length is 1. And I'm using an or operator to say either or, right? That's something we also learned earlier. And this part here is the recursive case, right? The else part, right? You can annotate just yourself. So this is the recursive case over here. And I would say this another kind of exercise you can also try when you're still at the beginner level for recursion. Every time you're going through the recursive case, try to visualize what's happening over there, especially how are we calling making the recursive call, right? Let's take a look. Okay, I'll show it to you. So just to start with, we have this input called word, which is an array of characters. So think about the word is our input, which is conceptually pointing to an array of characters. So you may have 0 and 1, all the way to, we know the last index should be the word length minus 1. Right? Of course, you can think about the second last index over here should be word length minus 2 instead, right? So that's to get some idea clear. And then what we're doing is we're trying to look at the first character and also last character. So we simply go to character at index 0 and the character at this last index, just like an array, right? Nothing surprising. So you can think about what we're doing here is we got this one here and we got this one here, right? First character and second character. So this is the first character and this is the last character, okay? And then we are trying to calculate the so-called the middle part using the substring. And this is to say I want to go from 1 all the way to exclusive word.length minus 1, which means we don't really include this one here. It should be to the left, right? It should be minus 2. So that means the middle is really about this particular part of the string. So this part over here is the middle. All right? So we kind of split the string this way. So these two characters are the ones we can compare right away. Whether or not we want to go with a further recursive call to look at the middle depends. So that's why you will see that we're using the ampersand operator here, because that one will evaluate it according to the short circuit principle, right? So this one here, right? Do you guys remember what short circuit evaluation really means for AND operator? There are two parts basically, right? Anybody? Give it a try. Yeah.
It'll only evaluate the second one if the first one is true.
I agree. What if the first one is already false?
It
doesn't do it, right? The whole thing is false. Very good. Okay, let's now write this detail down, right? Of course, for the OR operator, it will be symmetric. Okay. So number 1, if the left-hand side is true, you have to eval the right-hand side. Another scenario, if the left-hand side is false, in that case, you will skip the right-hand side. So here we are saying, if the first and if the first and last characters are the same, in that case, we have to look at the middle part to see if it's a palindrome. All right? If these two characters are already different, in that case, don't even bother. There's no way it's a palindrome, right? That's exactly the reasoning we talked about visually in the earlier page. All right? Guys, any questions so far just about this? Okay, we'll try to visualize, kind of like a recursive call for the later two problem as well. Yeah, question.
So my first thought was, instead of using like a return with an and, do we use an if statement? Like if first char equals last char, do is palindrome, if not.
Absolutely. You can definitely split it if you wish. Yeah. So if Alice's student was asking, is it possible? Okay, why don't we do it quickly? Okay, absolutely. So this part here, you can do instead. If the first character equals the last character, in that case, you may have to return the is palindrome middle. Otherwise, if they are not the same, in that case, you just return false. So they're equivalent, absolutely. Okay. So if an exam question does not pose any restriction about what you should really use, in that case, you can definitely use either way, right? But I will personally prefer maybe the short circuit evaluation, just a little bit less to write, right? But they both work. All right, so that would be some alternative implementation. You guys can also take a look, okay? All right, let's now trace one string very quickly, just to see how the recursion is going to work, okay? Just to get an idea. So what we do is, why don't we try calling its palindrome? I'll just say is P, just easier for me to write. And then let's say A, B, C, B, A. Okay, let's say this one here. Well, obviously, we can already predict what the result should be. Reading forward, reading backwards, A, B, C, B, A. So that should be returning true eventually. But let's see how exactly the runtime is going to figure out it's true. Okay. So when we look at this, apparently the length of the string is not 0 or 1. So we should go to the recursive case. Okay. So what we do is we look at the first character A. We look at the last character A as well. And also the middle part will be the substring, the rest, BCB. Okay? So now we got first, last, and also the middle. Okay? So this one here can be split to the first character A equals last character A, and is palindrome, the middle part, B, C, and B. Okay, follow so far? And now, short circuit evaluation is already effective. So what we should do is we should evaluate the left-hand side first. This one here should be true, right? This is true, so that means we should also evaluate the right-hand side as well. So we have to go further to execute this first recursive call, okay? So that one there, we do the same thing. First character, last character, and the middle, which is only one character, right? You can see first, last, and the rest, right? The rest, the middle part just happens to be one character string. And that one there can be, again, split into B equals B, and also is palindrome, and also C, all right? So, of course, we got N to combine them. And short circuit evaluation. We have to first evaluate the left-hand side. B equals B, true. That means we should go over to the right-hand side. The right-hand side here is now the base case because C here is now length 1. By definition, it is a palindrome. All right? So this one here is going to return true. At the moment, as soon as we return this case over here, we still got 1 and 2 method called suspended in the call stack, right? We talk about factorial, so you should be able to kind of visualize, right? At the moment, we are returning true, so now we should really calculate its palindrome BCB. That one there was suspended earlier because we were waiting for the result for its palindrome C, right? So now that one we know is true. So true and true is going to be true. So that means this part over here is going to give us true. And then we can now go to this suspended method here, right? So now we know that this is palindrome here is going to be true. So true and true is also going to be true. Okay, so that'll be the ultimate result. Of course, you can give a try on other string. For example, give it a try on the string that might return false eventually, but this one will be true. Okay, it's a quick tracing. You can see this is more like a high-level tracing without having to touch the call stack. But I think it's almost equally understandable. Okay. Questions? Okay. One exercise I will recommend you try. Using the same style. Give a try on this particular string to see if there's a palindrome. RACEACAR. Give a try on that yourself, right? Just try to use the same kind of a recursion tree and try to split the string into first, last, and also middle to see how far you have to dig into before you will see it's not a palindrome. All right, that'll be my recommendation. Okay. All right, if no questions, let's do a second problem for recursion on string. Okay, this one here again is a very common one we have to go through. Okay, it's called a reverse of string. Okay. Given an input string, you want to return another string. basically. Okay. So example, empty string is what's its reverse? Empty, right? If you try to read the reverse backwards, it should be equal to the original string. That's how you can tell, right? What about one character string? Just itself, right? That's why it's also easy to see. So these two are actually the base cases, meaning that if you're given the input string being of length either 0 or 1, you can just return that particular string itself because reverse will just be equal to itself. You don't need to do any computation. These are typical base cases. But if there's anything that's more than length 1, starting from length 2, you might have to do a little bit recursive call. So for example, AB, the reverse will be BA, right? Obviously. ABC, CBA, ABCD, DCBA. Right? At least we understand input and output, right? That's the first step to really towards your solution. And for this one here, okay, it's really for those of you who haven't really seen this problem before. I want to just pause for a moment to give you a chance to think about how you can figure out a solution, right? Don't feel any pressure, but I want to give you a chance at least to give it a try. Okay. So let's say this. Let's say this is the input. And we are calling, for example, the reverse. Okay, I'll say REV, the reverse of this. Right? That's an input string. I know that the output is going to be, let's think about input and output, that's by hints to you. It's going to be D, C, B, and A. Okay? I got 2 hints in total. Let's say the first hints. So now try to compare the input and output. Are you able to somehow figure out which part do you want to make the recursive call on? And then for the rest of the string, without being the input for the recursive call, you can combine it for the recursion result. Not yet. Okay, I want to give you a fellow student a chance. Okay. Just see why you can, that might come to your mind, because this might be something you have to, run into, in the exam, right? That's the first hint. The second hint goes like this. I'll make a visual. That's the second hint. So what am I trying to say in the second hint? I'm basically saying, when I try to compare the input and output, I noticed that the first character in the input is the same as the last character of the input, which is no surprise because I'm calculating the reverse, right? And this part here, the rest of the string, except for the first, and this part here, the rest of the string without the last, they look not exactly the same, but they're connected. How are they connected? If you compare the pink and the orange, how are they connected? Go ahead. Yeah, the orange is just the reverse of the pink, right? All right. So that would be some kind of like a trials and errors process you have to do for any recursion problem, right? If you compare these two, you can think about orange is the reverse of. Okay, so this is telling us if you actually want to calculate the reverse of a string, what I can do is I'll simply take the first character, which is guaranteed to be the last character in the output string. And then I make a recursive call on the rest of the string, which we call the tail of the string. And then make a recursive call on that. That one there, we can assume it's going to generate whatever that's right. And then concatenate these two parts together. Right? So that will be the sketch for the recursive solution. Any questions about this analysis here? All good? Okay. If you're okay with this kind of thinking here, let's now see how the Java code would look like. Okay. So let's now see this. So we got 2 base cases. When the string is empty, and when the string is of length 1, in that case, you return the same. Of course, you can make this a little bit like a shorter. You can say if the length is either 0 or 1, you just return the string itself. It's going to work as well, right? There are different ways you can write the base case. But anyway, so this part here are the two base cases. Okay? And then the recursive case is right here. And as before, let's try to visualize what the solution is telling us to give us a little more assurance about why it's going to work. Okay? We are given the input S. Okay? So think about S over here is basically a string, which will be an array of characters. Okay? In this case, we just have to split into index 0 and the rest. Okay? And then we got several parts. So let's start with this one here. So you got the head being the character at index 0, which will be right here. All right? So this will be the head. And then we also got something called the tail. It's going to be the substring from index 1, which will be here, all the way to the end. That'll be s.length minus 1, inclusive. Okay? So that one there is going to be the rest of the string over here. So this is what we call the tail. You can think about somehow given the input string, we are trying to split the string into head and tail. That's what we do first. And then the final result is going to be a combination of the head itself, but rather than appearing first, it's going to appearing last. And then this part over here is not tail anymore. Instead, it is the result from recursively calling the reverse of on the tail. So it's not exactly the same. Right? So let's see how we're doing. So now if we look at the output, right? So the output is going to be similar, but not exactly the same. So you're going to return another string. That one there is going to be the last character here is guaranteed to be the head. As you can see, right? Guaranteed. So this part here will be the head. Right here. And what about this part over here? Okay, so this part here is orange over here, which will be the reverse of tail. And that one is by making a recursive call of the same method on the tail, which is right here. Right? So think about this part here is really the reverse of the tail. Right? Right here. All right, any questions about this? All good? Okay. And then let's now trace one input. Let's say we want to calculate the reverse of something simple. Okay, let's say the reverse of ABC. So we say that we want to calculate the reverse of, I'll just say R. A, B, and C. All right, right here. Okay, so we're going to split the input string into two parts. So we got head right here, the first character. And also we got the tail, the rest of the string. All right, by definition, we're going to swap the order of the two, right? So now A should become the last character. So if we split it, it's going to be basically 2. So we know that A should now become the last part. Okay, let me move that a little bit to the right. Okay, we might need more space on the left. And then, so this will be A here, verbatim. And then the BC here is going to be invoked as the input for recursive call, R. All right? And of course, we try to concatenate them. Okay, I'll pause for one moment. Are we okay with this? Okay. And then, similar. This BC here is neither empty nor length 1. So, recursive case. So we're going to split it into the first character and also the tail right here. So that one there is going to be split into, so we know that B here should really come last. And C here is now going to become the input for the second recursive call. Over here. Okay, let me mention something aside. Okay, you can see that here, when we try to calculate the tail, right, over here, it's going to be the substring of 1 and also s dot length, right? Okay, so this is an edge case, like a special case. Okay, so over here, what if s dot length is exactly equal to 1, right? So here, let's say we got, let's say for example, let's say C here, right? Exactly what we are dealing with. In this case, the C itself is the head, the first character. What about the tail, right? In that case, you're going to say the substring. And over here, you're going to go from 1 to the length of the string minus 1, right? That'll be inclusive. But you can just put 1 here because that's substring, okay? So now if you look at 1, 1, that's also one of the edge cases we talked about last time about substring, right? This is going to give you empty string. All right, so that's something you have to know, right? Just make sure at some point when we want to call make a recursive call, you're going to make a recursive call on empty string, okay? So now, let's now try to split this one further. The first character is here, okay? And you can think about the tail is just going to be empty string, right? As we calculate it, right here. So that one there is going to be split into C will be the last character plus, so now it's going to be the reverse of empty string. Ah, yeah, you're actually quite right. Yeah, yeah, I agree with you. Yeah, actually, that's right. But, yeah, that's good. You should terminate earlier. I agree. Guys, good, good. Yeah, so of course, if I say I didn't really have this, of course, we would have gone there, right? That's good. Yeah.
That mean that the else if is redundant?
You can say that it's redundant, yes, you can definitely say that. But, on the other hand, sometimes, you may want to somehow trade in clarity for maybe efficiency. So there could be some advantage of listing some redundant base cases just to kind of reassure yourself you're doing the right thing, right? Yeah, I think you guys are good. You really pay attention. That's good. So let's fix it. Okay, I do apologize. So over here, okay. But I think what I just said about when you actually got maybe a single character string, the tail will just be empty. That one is also important, okay? So now for this one here, right here. Okay, that one there is just a base case. Okay, so now the base case is just going to return the string itself. Okay, just string itself. Just C. All right, so now we're ready to actually return. At the moment, these two methods are still being suspended. Okay. So now we got this one here, concatenated is going to be CB. And then also for this part here, CB concatenated with A is going to be CBA. So that's the final result, right? ABC, calculate reverse, will give you CBA. Okay. Questions about this? Okay, I got one exercise for you to try, right? For that one there, it's more like an alternative implementation for the reverse of. I'm also going to give you your visual hints. Okay, so now, let's just say input string, right? If I got A, B, C, D, so reverse should be D, C, B, A. But now this time, I'm going to say this one here, this one here, this one here, and, oh, maybe that one. Right, that's something you can try to see how you can implement using alternative approach. So this will be alternative approach for implementing the reverse of. Okay, I'll let you think about it. Okay. Should not be difficult, right? You still have to use substring, you may have to use character add, etc. Okay. Questions? Okay, good. Let's do a final recursion problem on the string, and then we'll take a short break. Okay, that one wouldn't take long. Okay, the final one. The final one is going to be something called calculated occurrence of certain character in some string. Okay, let's see this. So this method here is going to be called occurrences of string. It's going to take two inputs, some string and also some character. We are basically asking how many times the character appear in the string. So now we're asking how many times does character A appear in the empty string? 0 times. There's no way this character can appear in the empty string. And how many times does A appears in the single character string A? 1 time, right? Also obvious. And how many times does character A appears in a single character string B? 0, right? Hopefully get a feel, right? Just let's try a few more. How about this one here? How many times does A appear in BAA? 3. Okay, good. Okay. And then for B, it will be 2, and then C does not appear anytime, so 0. Right? I think got enough feeling about at least what should be the input and output. Okay. So this one here, let's also pause for a moment just to see how you can think about it recursively. Again, well, actually, so of course, intuitively, you might think about some iterative solution using a loop. I will do the same. But so now our focus is really to think about things recursively. So that's why we're just using recursion. Okay. So here, let's say we are trying to do ABCA as an input string. And let's talk about 2 different cases, character A, character B, right? So when I talk about character A here, I really meant I want to call the method, let's call occurrences. And then I got ABCA, comma, the character A. And then also character B, right? Just 2 different calls to the same method. And we somehow want to see how we can solve this one here recursively. Okay? The way you're going to split the input string can be just similar to how you split the input string for the reverse. Can be very similar. Yeah.
Or whatever character you set
Yep.
for you, and then if it contains 1 plus, and then you do it recursively on the substring. If it doesn't, you 0 plus and recursively on the substring.
Yeah, sounds very reasonable to me. Yeah. So what your fellow student just said was we can somehow split the string just like how we split for the reverse. Okay. So we can try to split that into maybe the first character A here, and then the rest. Okay, BCA will be the tail. So here, we're basically saying, compare A against the character A. Since they are the same, so this should be counted as 1 occurrence. So that should be counted as just 1. On the other hand, if the input character is actually B and A are not the same. That should be counted as 0 instead. Okay? And then, we should really also know how many occurrences does A appear in here. Also, does B appear here? That one, they were going to delegate to some recursive call. So that would be something like the occurrences of the tail, which would be BCB. And then the same character A. Occurrences of also BCB and also character B. All right, so that's one possible recursive solution. We basically take the first character, and then the rest is going to be up to some recursive call to figure out. Okay? Okay, let's look at the Java code very quickly and do some quick tracing, and then we'll take a break. Okay? So the Java code goes very similar to what I just said. So we're saying that if the string is simply empty, then it will be 0. No character can appear in the empty string for any time. Right? So that's the very reasonable base case, just 1. Okay, that's a base. And for the recursive case, let's now again visualize what's happening here. So what we have is we have our input string S and some input character C. So S is pointing to some input, let's say array of characters. Okay, and then we got 0, and then the rest. Okay, so we first of all get the head right here. Okay, when you get a head, it will be just the first character right here, and that one there will just be the head. And then the tail will be just a random string, the rest of the string, which will be right here. Okay, and the way we're gonna calculate will be two cases. Okay, we actually saying if the head is the same as C, it's gonna be counted as 1. Otherwise, it's counted as 0. So this part here, we're basically saying the head is going to be 1 or 0. 1 if head is the same as the input character C. 0 if the head is not equal to the input character C, right? So either 1 or 0. And then we're going to make a recursive call on this one here. That's the tail. So this is the tail. So whatever it is, we're just going to say plus the occurrences of the tail and then the same input character C. Oh, sorry, actually can't say here. Say C here. The visualization, right? We do the first one here and then make a recursive call on the tail. Question?
I was just thinking of the variant with if head equals C, the variant in C++ was equals to 1. So you can just do return this plus this. You don't have to do if and.
I agree with you in some way, yeah. But that solution, because I'm more thinking about your faculty of being beginner, so I thought this might be logically clearer. I agree with you. That one can work too. Yeah, 0 here in some ways is more like a redundant, right? Mm-hmm. I think for those of you who actually know about this notation, you can also give it a try, okay? Just for your Java. We can do something like this. We can say return head equals C question mark. If it is equal to C, it's going to be 1 plus the occurrences of the tail and C. Otherwise, it's just going to be occurrences of the tail and C.
And if I don't want to write occurrences of tails 2 times, I can do 1 and 0. And then
Yeah, you can simplify further if you want to, but that's just one possibility, right? Anyway, so this is just something if you want, you can look into what this character really means, right? It's not really covered formally in the course, but it's the conditional ternary operator you can actually use, right? That one there, I wouldn't ask you in the exam. You don't need to worry, okay? This character, but could be nice for your Java knowledge to use. Okay, you can look it up if you want to. Okay. Okay, let's do a quick tracing, very quickly. Okay. Let's now do something simple, and then we'll take a short break. Okay. So let's say we got occurrences of, let's say, make it simple. AB, the string. The character is just B. The ultimate result should be 1, right? So this one here can be split into, first of all, we know that the first character here is A, and the tail is a single character string B. So now we simply, so here we know that A is not equal to B. So that one should be counted as just 0. And then we're going to say that one there will be plus the recursive call. Occurrences of the tail is now just B. And then B. Okay? So that one there, you can now try to further divide. So first character is here, and the tail will just be empty string, right? So that one there is going to be split into, again, 2 parts. So the B and B are the same. So B equals B, that should be counted as 1. And then you're going to say plus, we're going to make a recursive call on the tail. Occurrences of the empty string, how many times does B appear? you can think about here is the base case, because empty string is empty. Should return 0. So this part here will just be 0. Okay, so now for this one to complete, we're going to do 0 plus 1, which will be 1. Finally, for this one here to complete, we're going to do 0 plus 1, right? That one will be also just 1. So that'll be the ultimate result. Okay, of course, you can try a longer string just to see how things will work. Right? Okay, any questions? So that's the only recursion problems on string we'll do in class. I think 3 of them already give you a pretty good idea. Hopefully keep you a little bit motivated to really try more recursion. Go to the coding bet, number 1. I think you can find some similar level of difficulty problem. Just try them out. Hopefully, ideally, all of them, just get more feel about how you can code out the recursion. All right? Okay, we don't need to take attendance today since I didn't take it yesterday. So why don't we take a short break only? Okay. All right, so just before we talk about how to do recursion on the arrays, your fellow student got a question about where to find a background study for Lab 5. So if you go to the Lab 5 instruction PDF on the E-class, okay, I'll show you quickly. All right, so important, you got to make sure you do it, okay, the background study. You will see that task number 1 right here, if you click on that, this is where you can find them. So you got slides, you got lecture recording, you got example code, etc. You can choose whichever that's going to work for you. All right, good. Yeah, it's a very useful topic actually, but given we already talked about inheritance so thoroughly, you should be able to understand it without any problem. Also, we're solving 2 interesting problems there using abstract classes interfaces. Well, you'll enjoy, the problems there. Good. Okay, so let's now move on to how we can do recursion on the arrays. We got about 28 minutes or so. I think at least we can finish off about the principle, and then there are only 2 examples I kind of plan to do. I'm not too sure if I will do them today. I can possibly do them maybe entirely maybe on Tuesday, and then there's one more example. I'll talk about it at the end. Okay, let's not worry about it just yet. Okay, we'll get to that point. Okay, how do we make recursive call on array? I'm just going to show you conceptually there is one way to do it, but that one is a bad way, which is very inefficient in terms of the running time and also space. But of course, we don't really talk about efficiency formally in this course. You'll worry about it in 2101, the follow-up course. Maybe if you take that in the winter. But I just want to give you some intuition about how you can think about, whenever you want to make a recursion on string, you create substring. But for us, you don't really want to create just a subarray because it's a very expensive way to do it. Let's see how we can go there intuitively and see why it is bad. Once we convince that it is bad, I'll show you one efficient workaround. Okay, so that'll be the way to go. Huh? Yeah, something like that. Yeah, well, we'll see. Yeah, have you seen that before? Huh? Kind of. Okay. Yeah. Okay. Good. Okay, let's start with, again, so what I'm talking about right now is intuitive, but it's bad. All right? Let's talk about it first. In general, if you want to talk about recursion on some input array, right? Input array could be array of integer or array of string, etc. Just array, primitive array. And you may have the typical base cases. You might say, oh, maybe the length is simply 0, or the length is equal to 1. In that case, you can do something for the base cases, right? I'm just showing you some skeleton, right? 0 or 1. Or if you really want to make it 2, that's also fine, right? You really have to go with the need for your particular problem. And here, we got a recursive case right here. Okay, so before I go over the detail for the code, I will give you, also you should really try to trace it yourself as well. Let's visualize what's happening here. So we're given the input array right here. Okay, so that one there is an array right here. That one there will go from, for example, it goes from 0 and then 1 and then 2 all the way to, let's say 99. 100 elements in the array. Okay, so that'll be the input. In the recursive case, we want to somehow make a recursive call of n, but we should really make it on something strictly smaller, like a substring. Right? So let's say given that the length is already 100, let's make it 99. all right? You can think about what we did earlier. Think about this will be the head, and this will be the tail. How do we get a tail, right? So what we do is we create another array, which we call the sub. We call it a sub array. That one there is going to point to another array of size 99. So that means the indices will go from 0, 1, all the way to 98. So now, how do we create this pink array that's going to correspond to the tail? Okay, basically, you have to, first of all, create a new array with the length -1, right? So you can think about this array here is exactly one element shorter than this original array. And then you have to do some copy over here. Once you got the array over here, index 0 over here should really correspond to index 1. Index 1 should really correspond to index 2. Index 98 should correspond to 99, right? That's a pattern. So convince yourself this copying process over here is exactly what we're doing here. All right, let me say that again, okay? This is the original array. And in order to make a recursive call, we got to create something that's strictly smaller. Let's say we split the array in this way. We got a head, and this part here is the tail. In the old array, input array, it should be from indices 1 all the way to 99. But now in the new sub-array that's one element shorter, it's going to be from element 0, index 0, all the way to index 98. So this sound one-off correspondence over here. So you can see here, what is in the sub-array over here is going to be 0 correspond to 1, and 1 correspond to 2, and etc. Okay? So convince yourself this particular part here is really doing this copy. Okay? Tracing. Okay? In simple trace. And it will create this one here. Okay? Of course, depending on how many recursive calls you will end up having in the recursion tree, you will have to create this many subarrays. Okay? Each time you create a subarray, you have to run a loop and do the copying. And you're taking some space. And you're duplicating elements in the memory. Right? That's what we can see. Let's see one example. And then let's explain why it is bad and see how we can improve it. All right, so over here, let's say if we got some empty array, and then you simply make the method call on the empty array. That one there is good because you simply hit this particular base case. So nothing else you should worry about. So this is simply a base case. Number 1. On the other hand, let's say we have some recursive case because we got some array of size 3. All right, let's see what's going to happen here. If I try to make this method call n on this array of size 3, so I got 0, 1, 2, and then I got A, B, and C. The length is neither 0 nor 1, so we have to make a recursive call. So the first recursive call, we're going to call n on some subarray. That one there is actually going to copy this part of the array, right? Disregarding the head. So we're going to make a new copy of the array that's going to be index 0 and 1, and then B and C. So that's the first copy for the first recursive call. And this one here is also not a base case. So we still have to do another recursive call. And that one there is going to make another subarray. In this case, size 1, index 0, and that one is going to be C. Okay? And of course, once you get to this part over here, this is reaching the base case right here. Right? This is a very, very small array that we are trying to handle. Even that, we have already duplicated B and C, right, of these elements. Imagine that if we got an array of size 1,000,000, you have to make this kind of copy 1,000,000 minus 1 times, basically, right, using the loop. You just imagine how inefficient or how much space it's going to take.
Each time is elements, so it's n squared.
Something like that, exactly, yeah.
N times n plus 1 over
Yeah, so I wouldn't really go to exactly how inefficient it might be. It's something we have to study. Well, if you study with me, right, next term, or your other professor. So that's something you will have to study about exactly how to use a mathematical function to formulate the inefficiency. Anyway, okay. So all you need to know is this is very inefficient, especially when the array size gets large. So we're going to say just for this part here, right? For every recursive call, so the time and space. So when I say time, I really meant about running the loop, right? And the space is really about the subarray that we are creating. Wasted to create subarrays between recursive call. Recursive calls. All right, so let's understand that this is bad. All right. However, the idea is not bad. The idea is really legitimate. You want to make a recursive call on something that's strictly smaller. But now, how do we do this one here? All right. So the solution to this contains two parts. Number one, we want to make use of call by value. So rather than creating a subarray, we simply pass the reference of the original array, call by value. So we don't really create anything new in the memory. The second ingredient is about using, as you said, using some interval. We can specify what should be the beginning and the end of the original array you want to look at this current recursive call. Okay, roughly speaking. But let's see exactly, conceptually, how that's going to work. So now we're going to talk about basically the similar idea, but now let's make it efficient and also still correct. Okay, so this one here, let's see. We have some method n, but now this time we got input array still the same as before. But now we got from and to. Okay? Sometimes for some problem, you don't necessarily will need a from and to. You might just need one single index. That might just be okay. But you know, I want to make it very general for you. So that's why I got from and to, like a left and right, you know, boundary for the interval. So think about the from and to over here. So this will be the range of indices to inspect in array A right here. And you can think about when we say the range of indices, we are essentially creating subarray, but in a very efficient way. We don't create any new array objects. We're just using integers to specify. Okay? It's quite a clever idea, actually, you know, to really use. So that's really for us to create subarray. I'll put in quotes. Okay? Well, let's dive a little bit deeper, and then I'll show you an example. So over here, we say that if typically we got two base cases, typically. Let's look at this one here. When the from is equal to 2, for example, if I say I want to look from index 2 to index 2, that means I only want to look at one single element at index 2. All right? So that will be base case. This is essentially subarray of size 1. When the from is exactly equal to 2. Another boundary case is when we have from larger than 2. For example, if I say I want to go from 3 to 2, there's no index that's going to be between 3 and 2, right? No way. So this base case over here will be as if we're talking about a subarray of length 0. Subarray of size 0. Okay, subarray of size 0 and subarray of size 1. Okay, and these two are very similar to the I and j we have to specify for substring. They're really consistent notation, right? They're not inconsistent, right? That's something you can also revisit together with the substring. All right, let's now take a look at the recursive case. One possibility is we are making a recursive call, right? First of all, this is a recursive call. So this one here is a recursive call. Recursive call. Okay? And the first A over here is call by value. Okay? It's a star. So the star here is call by value. We are passing the reference of A around. Rather than creating copies of A, we're only passing its reference between the recursive call. We'll see that even more. I'm going to trace something together with you. Okay? And this part here, okay, let's now compare. The input over here is from and to. And when we make the recursive call, it's actually from plus 1 and 2. Okay? How do we visualize this, right? Let's take a quick look. Okay? I'll put it aside here. So if you think about, let's say this is our input array. So that's our input array, let's say A. Okay? Let's say, hypothetically, let's say this index over here is from. Okay? And this index over here is 2. Okay? Just make it simple. From is the first index and 2 is the last index. Doesn't need to be, right? Just say for illustration. When I say from to, I'm basically saying I want to look at the entire range of the elements in the array. On the other hand, when I say I want to look at from plus 1 to 2, so you can think about from plus 1 is the next index, right? So this will be from plus 1. And that one is saying I want to look at this part of the array. So when I initially try to look at A, this array over here, from to 2, which will be entire array. When I want to make a recursive call, I'm still passing A, the same reference, but now I want to look at only from plus 1 to 2, which will be this subarray. I'm not really creating any new array objects. I just changed the indices I want to look at. Okay? That's the first illustration, but let's now do a little bit tracing. Okay? Let's see how this can be used in the actual coding. Let's now look at some scenario. Let's say I got A1, which is the empty array, right? Of course, you know that A1, the length is simply equal to 0. Okay, that's obvious. Okay, and then I actually got A1 over here. Okay, and then I want to say from 0 and then to the length minus 1. You can think about this more like a last index. I'm basically saying this is, given any array, this will be the first index. And this one here will be the last index. However, A1 here is a very special case. It is empty. So what does that mean? So this one will boil down into, I basically say n, but I got A1, 0 here. A1 dot length is 0. 0 minus 1 is going to give me minus 1. What does that mean? That means I want to look at A1, but between index 0 to index minus 1. This is the case where we got from larger than 2. This tells us we got some empty range of indices to look at. Or you can think about, effectively, this will be the empty subarray. Let me say it again. Okay? In general, when you actually want to first start with the method handling, you will say, I want to pass on array A, in this case A1. And then I want to inspect between the first index, which is usually 0, always 0, and also the last index, which will be A1 dot length minus 1. But now in this very special case, A1 is actually empty, meaning that A1 dot length is actually 0. 0 minus 1 is going to give me minus 1. and I start with 0. So this from and to is going to give me some empty range. So in the empty array case, I just have nothing to look at. That's it. Okay? It's just a base case. Let's look at the not base case. Let's say here we have A2. Okay, we got ABC. So index 0, index 1, index 2. And also we know A2.length is equal to 3. Okay? And then we're trying to pass the A2. And then we go from 0 all the way to A2.length minus 1. 3 minus 1 will be 2. All right? So we're going from index 0 to index 2. What does that mean? So what we do is, when we actually try to make a call, let's say A2. So A2 is now going to be the array 0, 1, and 2. Okay? And then we got A, B, and C. Okay? So when we, let me do some visual rehearsal, and then I'll try to maybe open a new page and try to trace again. Okay? I think that'll be a little bit easier. So we first of all try to look at the entire range, which will be from 0 to 2. In that case, we try to look at the entire range. Okay? The first recursive call, we are going to increase the from. In that case, we're going to look at 1 to 2. And then the second recursive call, we are going to increase the from, which will be from 2 to 2. So these are the three ranges we're going to end up having to inspect. But let me just trace it again. Okay? I think I want to give you some visual look ahead first. But now let's now see how we can trace it. Okay, I'll put it in another page. Right here. Okay, let's now give it a try again. So what we have is, so we got method n, A2, and then 0, and then A2 dot. So let me put A2 here. So we got indices 0, 1, and 2, right? We also got A, B, and C. Okay, A, B, and C. Okay. So when we first call the method, we're actually going to have 0, 0, and also A2.length, which will be 3, 3 minus 1. So it's going to be 2. Okay, we'll start with this one as the initial call. Okay, so this one here, 0, 2, essentially is talking about we're going to look at all the elements, 0 to 2. Okay, that's the correspondence. And then here we're going to have the first recursive call. So this one here is going to be n. We're still passing A2. We're not making any subarray. So now it's going to be from plus 1, 1 and 2. All right, 1 and 2 here, and that one there I can put green. 1 and 2. So that one there is going to be 1 and 2. Only look at those two elements. And then we got m here, and also we got A2 from plus 1, which will be 2 and 2. Okay, so the final, this will be the base case. I'll show you. So this 2 and 2 here, that means we're now looking at the last elements right here. Okay, so now if you go back to the original code right here, whenever you're seeing from is equal to 2, that means we're looking at just one single element in the array. In that case, we don't have to go any further. That will be the base case. Okay, so this would be the base case. It would be as if subarray of length 1. And this will be subarray of length 2. And this will be the original one. This is the input array of length 3. So this is just one example pattern for the recursion. So as you start with the array of certain index range, you just have to keep narrowing down the ranges. Over here, as recursive call are made, you try to narrow down the intervals. All right, any questions over here? This will be a pattern you will have to program. You know, we're gonna see 2 examples, maybe not today. We can do that maybe next Tuesday in the last class. But you gotta make sure this one is understood first. Because the way you kind of narrow down the intervals may not be just using from plus 1. That could be the typical one, right? From plus 1, from plus 1. Sometimes it could be that you want to say from plus 1 and 2 minus 1. Right? You're still narrowing down the indices. It really depends on the situation. Okay? Questions? Okay? Get yourself familiar with the recursion on the string and also on this particular pattern here. And then we're going to do the final 2 examples. The Tower of Hanoi example there, I'm going to give you some recording. You can study through. Also, you got the slides. And that'll be it for the exam. Okay? I'll talk about the exam as well next Tuesday. Okay? I'll see you guys.